So yeah, we're going to be building this kind of workflow today. So it's using matrices or a transform matrix to allow us to basically build this noise and parent it to like a rest position or a standard coordinate space that's non-deforming, but it gets applied to the moving character. Jonas.com, good to see you. Jabram, how's it going? Aldo 3D, yeah, so we're building this thing today. RH2, how's it going? So yeah, we'll just kind of jump in. We'll get started with this tube. Getting coffee. Sometimes you need coffee. You need a little boost for some more technical stuff inside of Houdini. So this is just a demo. The Utah monolith. I've been looking at this. It's pretty impressive. Did anyone locate it? Yeah, you could put it into the Antelope Canyon. I've heard that they're not disclosing the location because they don't want people to go visit it. So yeah, we'll just get started with this tube. And then I'm gonna do a basic example using a tube, and then we'll move over to the character. And sometimes when you're building like more complex tools or just testing workflows and stuff like that, starting with a simple kind of test case can be a better method than like jumping into a fully complex scene. It's like a heavy scene with a lot of data or a heavy mesh that just takes a while to cook or process in Houdini. It makes sense to just try things out on a simple object. So we have some twisting and bending happening. Basically just a quick way to make some kind of somewhat procedural animation. And if we just jump in with the cloud tools, can use this to convert geometry. Nell Piper, how's it going? Convert the hard surface geometry to a fog or to a gas, to a volume, and then the cloud noise. And let's just get a light in the scene. Ah, Nelson. All right, so we have a light, usually just for visualizing it. I'll turn off the attenuation, and then I can just move it like off in the distance somewhere. I don't really have to worry about it. You could increase these divisions if you want a little bit more resolution. And let's maybe make this. Actually, I'm just going to change the element scale. So just trying to get something a little bit lower frequency, like bigger feature size, so bigger element scale. And sometimes this alligator noise, I tend to think it has a little bit better visual properties, like getting you closer to clouds. All right. Jay Walker VFX. I'm doing all right. I'm hanging in there. It's close to Thanksgiving here. Getting my feast ready. So we have this cloud. And you can see the problem. Let me change this as well. So you can see the problem is that this is swimming through the texture, or the noise isn't parented, or it's not constrained to the surface. Feast for a beast. All right. So this is the issue we have. If we want to deform space with this, we need to build out a little bit extra stuff. The way that I've usually done it is I'll use a polyframe node. And if you kind of zoom in on the icon, you see that each point or each vertex has its little local axis. So that's what I'm going to do with this. If we look at, not much to be thankful. At least we have our computers and our internet. So we have a normal right here. I'm just going to visualize it. So this is pointing outwards like this. Then we also have a tangent that's kind of flowing along the surface. And it's kind of important to see that these vectors or these directions will deform along with the operations that we applied to the surface. And the last thing is the bitangent that's going kind of around the shape. So all of those axes are very similar to this gnomon at the bottom left of your viewport, like a 3D coordinate scheme. Thankful for the streams, of course. Glad to share the knowledge and give people something to do during lockdowns, hibernation. The hibernation station. So we have the different directions that are local to each polygon. So I'm saying local to each polygon because they're deforming, or they're matching this like new space that we're defining as we move things around. So right now I'm just blasting them all into N to visualize them more easily. If you want to label them a little bit more cleanly, you would say that this is like the Z axis or ZAX, and this one here that's kind of going up along the shape, we could say that that's the Y axis. And sometimes I'll turn on this make frame orthogonal. So I think this will just kind of make sure that you have a rigid kind of transformation frame. So this will just say local frame. And you can do the last one here. We could do XAX. So now we have our three vectors, XAX, YAX, and ZAX. If we look at the spreadsheet, you can see them here as well. Vegan Nuts, how's it going? So I'm going to set up a wrangle here. And we can define a transformation matrix using this. So if we just say matrix, call this live. This is like deformed. We'll set it equal to the x-axis, the y-axis, the z-axis, and then in the fourth kind of column, but this would be the fourth row, we'll just use the point position. So this is our deformed matrix. And then I think that we want to set, usually I'm doing it like this, deformed, you want to zero out some of these components and stuff. You just get my little cheat sheet up here. All right. So we can do XW. So this is like the row column order. If you look at the Vex syntax in Houdini, XW is basically saying, so it's X, Y, Z, W, and then it's column row. So I believe it's like, kind of like if you use Microsoft Excel, it's it's kind of two coordinates, or it's like saying that. So if you look at right here, nomenclature, it's a quicker way to refer to the data in a matrix. So the matrix, you have all of this information. When we have X axis, that was filling this first row with the X axis. This is a bit like kind of too much information, maybe. You don't really need to worry about it, but this is how it's constructed. And then XW is basically saying the first row and then the last column. So this is X, Y, Z, W, and then this is X, Y, Z, W. Hopefully that makes sense. If you want to check it out, you can visit that page as well. So I think we do this. So we're basically only worried about that last row. We just want to set it 0, 0, 0, 1. Because all of these vectors don't have a fourth component. They're just 3D vectors. So they just have like X, Y, Z values. So we're setting the W values for each row in our new matrix. And then we're going to do another matrix. It's going to be the rest position. Let me just set it to 0. I'm going to pump it in like this. We're diving into the matrix. So I'm going to pump it in like this. So basically our undeformed state, or before we modify or move any of the point positions. And then I think that there's different ways of getting this information. Like if I just set P, if I want to transfer the point position from this input, as an example, you can do op input 1 underscore P. And that's a shortcut to kind of do it. In the Vex documentation, they talk about this, maybe in this area, like accessing here it is. Access a different input using the op input n name. N is the input number. You can also use the point function because this is a point attribute that we're reading. So as well, if you wanted to, you could set it up. You might have seen people do this. So you're getting a point attribute from the first input. You're getting the position attribute, and then you're just matching it by the point number. So this is kind of doing some extra work. Under the hood, it's like automatically knows to match by the point number. So I'm just going to keep with this because it's a little bit more concise. It's a bit of a shortcut. So we'll fill the matrix out this way. And I just want to get the axes from the rest. All right. So this is a bit easier to do using Wrangle. You would do it using VOPs, but it's a lot of extra wiring and stuff like that. So I prefer to usually set this stuff up using a Wrangle. So now we have our rest matrix. We need to do the same thing here in terms of, holy crap, a tube. This is the monolith. This is our desert monolith that we're all hypnotized by. So we'll do the same thing with our rest matrix and just setting the fourth column for each row. So the first row is 0, the second row is 0, the third row is 0, and then the last row is 1 for the last component. So if we go back to our thing, XW is this one for X, and then you go over X, Y, Z, W for columns. So we're setting this 0, 0, 0, 1 to kind of match this identity matrix. And then we're gonna make a transform, and the transform syntax or the naming scheme like this is like a standard Houdini naming convention, so that's why I'm calling it transform like that. And I just want to set that equal to the inverted rest times the deformed matrix. And then that's it. So we should be good with it. And this one, we'll just say this is initialize transform matrix. And maybe in the comments, this is the difference of the deformed and rest spaces. So what do we do with this? It doesn't look too good or anything like that. It's just sitting there on the geometry and it's not too helpful. But this is kind of a guide, or this is a little coordinate space that if you multiply the point position by the transform matrix, this will tell you how to get back to your rest position or your undeformed position. So times equals 4 at transform. Oof, uh-oh, done something wrong. Let me investigate here real quick. All right. So I just wanted to invert this. The invert is whether you're going like to the rest position or from the rest position. So to go from the live, like deformed position to rest, you multiply by the inverted matrix. And then if you want to go back to your final position, you don't need to invert it. So I'm just going to make a null node that's going to be a reference here. Can get rid of these spare parameters. And then this, I'll just say this is our local frame. So you might be thinking, like, why is this helpful? So is it a 4x4 transform attribute, some 16 transform in the geo spreadsheet? Yeah, in the spreadsheet, the way that Houdini represents it is it's an array of 16 values. So you transform 0 all the way through transform 15, 0 through 15, or 16 total numbers. You could look here as the last column. You can see I've set it to 0, 0, 0, and 1. I think I'm getting it. A miracle. So yeah, it says 16 floats or a matrix. So basically in the spreadsheet or internally with the computer, if you like ignore all the commas and brackets, this is just 16 total numbers. And then if you were to write it down like in your math textbook or whatever, you would space it out in terms of like a spreadsheet or like that. So you might think like, why is this helpful if we had a rest position? You could swap P with rest to get back to your original position. And this seems pretty easy. And for most cases, like if you're texturing things, this will work and it will be useful. But the issue is that it doesn't kind of extrapolate the space out into 3D. It's just like a texture that's stuck to the surface. So if you have a point that's over here and you want to parent it to the deforming geometry, you can't really do that task. So if we just want to visualize what I'm kind of saying, we'll make a box. Let's go up. Just going to try to fit the tube inside of it. And we want to do some divisions. It's like some internal kind of skeleton. And we can get the transform matrix and use it to distort space for this like kind of lattice I've constructed. So what I'm going to do is connect up this deformed to rest, and I'm going to do a XYZ dist function. So I usually make the primitive number and the primitive UV variables, and then you use you use XYZ dists. We're going to get the first input, the auxiliary input. We're going to query the nearest 3D position on the geometry to the current point position on this lattice. And then we're going to record the primitive number and the primitive UV that's nearest. So if we just do P equals prim UV, this will give us the point attribute that it's found on that geometry. So this is the nearest position on the surface of the tube after we've moved it into that rest space, just to visualize what's happening. But instead of that, what we can do is get the transform matrix. And we can use the same primuv function to do that. So any attribute you want to get on the surface of the geometry or from this geometry, you can get it with the primuv function. And it's pretty nice because it will interpolate over the face. So if you were to just do near point or find the nearest like 3D point position, it won't interpolate over the face of the geometry as smoothly. And then if we're going from rest or from undistorted like world space to deformed space, we just multiply by that transform vector, or I'm sorry, the transform matrix. So P times equals transform. And then this is pretty nice because we've basically parented all of this geometry to our deforming animation. So if you're used to like working with rest, you would never be able to preserve like a rigid kind of parenting scenario like this. You can basically stick geometry to the surface, but you don't have any concept of like its distance or a parenting hierarchy like this. And then, of course, if you wanted to go back to the like rest position, you could multiply this by the inverted transform. So this can be useful if you want to do some operation in deformed space or something like that, or if you just want to keep going back and forth, this is just the steps to just go. Yeah, it's kind of like a lattice deformer. It's pretty nice though, because you can, it's like arbitrary geometry, like it will work on any geometry, and it's pretty easy to apply to other things. So if you're doing even, maybe in this one, a bulge kind of operation or something like that, you can see even the space can be getting squished and stretched and stuff like that. So this is expanding or contracting like the 3D space around it. So it's even like a warp or like a suction or something like that. And just simply using the rest position, it would never kind of record the expansion or compression of space like that and be able to extrapolate it outwards like this. So working with volumes, you need to know a little bit of the extra space to be able to it's like when I'm inside my transformer. So this gives you an idea of like 3D space and how it's being transformed. So if we want to have the cloud noise, using this attribute, we need to unlock it and do some stuff inside of it. So just go allow editing of contents. So it's kind of unfortunate, but this is the only way to build in this support. If you wanted to do it using a custom, like you could build this VOP as a custom standalone thing. But just the way that SideFX is set it up, you can't supply like a rest matrix or anything at the top level. So you just need to build in or kind of hack the support in yourself. So with this object merge node, I'm just going to go up a level and fetch the local frame transform. So this is our 3D space. This is our cloud in 3D. And then we can use this geometry here as a template to get back to our rest position. So again, just looking here, if we take P and multiply it by inverting the transform matrix, we are back to the rest position. So if we do some noise, in this rest space, and then we go back to our original position, you can see the noise sticks or swims, doesn't swim with the geometry. If we don't do these steps, then you can see what the issue was, or the problem we had before. So we just need to do the same stuff, but with this cloud noise VOP. So I can just connect this using one of these auxiliary inputs. So this is going to be input 2. So all the internal like VOPs and VEX refer to these inputs like 0, 1, 2, 3. What if your object has UVs? UVs is kind of like a rest coordinate here. You can't parent, like it doesn't kind of keep track of this 3D space like it. So it's not going to be as good. I could show you what happens with this and the difference after we finish building this. And then sometimes if I'm ever editing HDA, I'll go in and any node I'm adding, I'll color it red. So this is just an easy way. If you see an asset that's unlocked like this, basically you have no idea what has been changed unless you do like a diff operation or a more technical comparison between the edited and the live HDA or the unedited HDA. So it can kind of create a mess if you don't know what people have changed. So that's why I'm coloring anything that I'm adding or modifying to a red color. So we could do the XYZ dist. This is the same VEX function we were doing. We're just gonna use this to get the primitive number and primitive UV of our geometry plugged into the second input index. So the input right here, we just go, here it's called third input, but this is again just like the difference, the different naming conventions, they kind of make it confusing. All right, so then we're gonna do the primitive UV. We're in VOPs, they call it primitive attribute, but then when you put down the node, you can see it's still the same function. So again, the file or the input number we want to use is the same. And then we're just telling it from these positions on the input, the auxiliary input tube geometry. And we'll get the matrix attribute. So with these two nodes, we're basically saying for every voxel of the volume, find me the nearest position on this tube and give me the transform matrix that's on the nearest surface position for every voxel. And then if we just do our multiplication, and we want to multiply the current voxel position by our inverted matrix. So this will give us, if we use a null, this is the rest position. So if I take our noises, this is the AA flow noise. I think it's used for the advection tab of the input. And then also this for loop here, I can just replace it with this. And then you can see our result has changed. So these are the only steps you really need to do inside of the cloud noise VAP or the cloud noise volume VAP. And then that's pretty much it. I've replaced the noise inputs. So there's this AA flow noise that's used for this advection. So the advection, might need to change some of these settings, but it's basically warping the coordinate space. It's like moving, they call it advection, but it's similar to what I've done before on different streams where you warp the 3D space using a noise. So if you look at the amplitude here, this is just how much you're warping or distorting your final like displacement noise. So I've basically set that advection noise and the final noise here to read from the rest position or the rest space of the tube instead of the live. So if we go back, this add was originally plugged into just our world space noise, world space position, and we get this swimming. But if instead of that we say, don't generate a noise from the current position, just generate a noise from the rest position of the tube. So all of these voxels will kind of get moved or generate a noise from this fixed point position. Because this is basically the operation we're doing. It's kind of, if we take this lattice, like this is, let me do another example here. So let's take these boxes. Let's just have it generate points. So this is kind of like a visualization of the volume or a bunch of voxels. And in the volume VAP, we've done the XYZ dist and we did the primuv function. And then if I take our current point position and multiply it by the inverted transform, and do it at this step right here, this is going to tell us how to get to the surface of the geometry. But it's extrapolated outwards instead of being fixed on the point position. So does this kind of make sense? We're warping like our world space to be back into a kind of object or like deformed space position. So if I go here and generate a noise, can you do a noise? This is the alligator noise. We want this to be just like a black and white value. So what we're doing inside of the VOP is kind of saying we have a noise position, and that's equal to the current voxel position transformed into the cylinder's space. So say the color, and instead of generating it from world space, like this was originally set up to do before I unlocked it, hold on. We're copying this and generating a noise using that step. So the volume, the voxels are generating the cloud texture or the cloud displacement being warped into the rest position. So I think, let me just make an output down here. All right, get rid of those. Just the regular output. This way I don't have to worry about moving the display flag around. So with volumes, it works a little bit differently than points. That's why I set it up this way to kind of visualize what was going on. We were basically generating this texture like in a deformed space, if that makes sense. Because it's a volume, you need to know, like, you need to do it spatially. It can't just be done on the surface. Yeah, I could even share this scene. Yeah, so let's just say this is like 3D noise from rest space. So if you want to get the scene file, just a first distribution of it, you guys can check that link. So could also make this red. Originally, all of these noises were using the, let's call this world space, which is just the position of the voxels. So this and this were originally set to use just P from the volume VOP global input. So instead of that, just switch to this position. So if we do this, this is exactly the same as going back to the current definition, or like nothing has been done. There's no difference between these two. And the only thing we're doing is, instead of using the global, the voxel space position, we're changing the noise lookups to happen from the cylinder space, but being transformed into the cylinder space. So we're basically doing like an invert distortion, saying distort our voxel space position to conform to like the cylinder. But because we've set up the matrix and done all that stuff, we're able to embed like all of the compression and extrapolate all that stuff out into 3D space. So if you wanted to do another lookup, like I've also assigned rest here. Let's just make another copy. So this will say, you just spread this out. This will just be world space. This I'm going to call local space. So I refer to this as a local space because it pretty much is like a new coordinate system. So if you're familiar with polar space, Cartesian space, UV space, or rest space, or all that stuff, this, let's just say XAX, we'll make this I'm going to have this be a tag. Style. Sorry, it's been a minute since I've done this. I think they changed it. So this is going to be X axis. I think I want it to be marker. Instead of text, have that be a vector. If this is X axis, we'll have it be red to match the gnomon down here. So this is the X axis. Can make another, I think if you click this one, you get another one. So this one is Y. And for Y, we're gonna just use green. We'll just duplicate that. So now we have a third one. And then this is the Z axis. And for that, we'll use blue. So as this space deforms or distorts, you still have a local coordinate system or a local frame. So that's why I'm calling it local space. So instead of just knowing, if you use rest, all that you know is like the 3D point position, but you don't know anything about like the derivatives or the Tokyo Megaplex. This is the biggest brain. So you don't know anything about the derivatives or like how this stuff is deforming or distorting. We'll just do another visualization here. And this one, I'm gonna go into the cloud noise, and instead of modifying any of this stuff using the matrix, we'll just have this get the vector attribute that's going to be rest, and you could generate the noise from that. And you can see it just doesn't give you as good of a result in terms of the compression and stuff like that. It will still look kind of nice, like it's stuck to things. But if you want to get, with clouds, you usually want to get, you try to have it just some super big distortion so that it's kind of actually like detaching from this from the surface. So we did these settings. You just pass them over. You can see we have these issues around the geometry because it's not recording like the actual 3D space. It's just projecting from the original surface, if that makes sense. Yeah, you might need to review it a little bit. I mean, I'm demoing this just so people know the thought process behind it, but you can also just use it without really knowing too much about what's going on. But basically this is just projecting the rests. Whoops. projected. So if you want another, maybe another way to visualize this, if you do the volume slice like this, and again, I'm going to use the wrangle, and then this one we'll plug it in like that. I'm trying to think the best way to stay organized. Sometimes if you have a lot of wires and stuff like that around, sometimes I'll just start to use object merges. So this, you can kind of set it up like it's a fetch. So you just do that, and if we go to view, dependency links show for selected nodes, you would kind of see like the wire and where it's coming from just when you select the node. I usually just keep that off, but just as a reminder, if you wanted to really see what's going on with a file, you can see that. So let's just say this is fetch local frame transform. And here, if I just set the color equal to the position, this is the world space, what I've been calling this world space point position. So as the cylinder and everything moves around, nothing really changes in this 3D space. The bounding box of the volume and stuff changes, but this actual coordinate system isn't deforming or distorting at all or anything like that. So if we do what I was visualizing over here, and just do the XYZ dist and the transform, just say this is world space coordinate visualization. So just need to always make these, it's kind of a pain or whatever, but the way that primuv works is it needs these variables to store the coordinates in. So it gets the primitive number and the UV position, the primitive, like, forget what they call it, but if you ever look at the Houdini primitive parametric space. So that's what the, it's not a UV like you textured it. For each face has the primitive UV, or it has its own like 0 to 1 kind of intrinsic or parametric coordinate space. So that's what this is doing. And like earlier, what I said, how it interpolates the value, that's what this is using it for. So instead of just giving you the matrix, the transformation matrix for this face, it will interpolate it across the face. So it can, without having to like subdivide your geometry crazy high or do stuff like that, it can bend or rotate the matrix across the face. So we'll take this, and we just want to find Galactique. How's it going? We just want to find the nearest position on that surface. So from this input here that we fetched, and from our current 3D position on this grid, or the volume slice, this will store the primitive number that's nearest, and then the primitive UV intrinsic position. And again, just to visualize, if we set P equals to prim UV, um, surface position of the nearest primitive number and that parametric space. That's what this is doing. The XYZ dist is giving you the nearest surface coordinates. Makes sense. Yeah, it's kind of, so it's basically just each primitive number, like if we visualize it here, it's telling you the nearest primitive number, and then it's giving you the X and Y, like it doesn't really use Z, but it's giving you the position here. So over 3D space, you can interpolate things properly or whatever. All right. So again, this isn't that helpful. What we want to do, sometimes the viewport messes up. It's like tessellation or whatever. What we want to do is take our color and visualize the distortion or the new coordinate system. So we'll take our current point position and again multiply it by the inverted matrix. I need to retrieve it from the geometry. So I'm going to say matrix like that. So this is a kind of way of telling the primuv function what type of data you're trying to retrieve. Sometimes it gets messed up because this can be used to retrieve vectors, floats, matrices, integers, all kinds of different stuff. So setting it like this is the same idea inside of these VOPs, doing the drop down here and telling it what kind of information you're going to retrieve using it. Sometimes you don't need to do it. Like here, it's smart enough to know you're assigning it to a vector, but as a precaution, sometimes I do it this way. It's called decast. Yeah, it's the operation that it's doing is called decast, but basically sometimes it's smart enough to autocast or shorthand notation in initialize. Yes, I went over it. So I went over this kind of stuff at when I was setting it up. If you go into the VOD, you will see it, but in this, yeah, no worries. In the Vex, just language reference, it's a shorthand for doing, just addressing different parts of your matrix. So XX is equivalent to this element, row, column. So this is kind of like if you're playing Battleship or whatever. It's a way to refer to coordinates or positions on a grid. Yes, that part is in this language reference as well. It's just a shortcut to do less typing. This is kind of a mess. They have too much stuff in here. As I said, at op input n. Where did it go? We need to review the VOD. I think it was. I'm not sure, but if you go to the VOD, you'll see it. I think I had linked to it earlier. But yeah, it's just shorthand for binding the attribute. So we're getting the transform matrix from the nearest primitive number and then the primitive UV attribute of that primitive number. So you can see the kind of warping of the 3D space this way. So this here, these .xw is like matrix components. I think you can do these brackets if you prefer. So like x would be 0 and w would be 3. Maybe I need to do a dot. I'm not sure. But it's the same idea if you've done other programming languages, like going into arrays and stuff that way. So set this back to x, w. Yeah, the warping space stuff is pretty valuable. Sometimes people will visualize the warp space using a sine function. So if we just do this, we're looking at the height. If you do a sine of that, then you can kind of see like the 3D space and how it's like extrapolated out and deformed. So this is what we're doing using this local frame. And if we want to just put this under this one, we'll put this one here, and I'll still refer to the same node here, but here we're gonna fetch just the rest attribute, zebra space. So again, this XYZ dist, what we can do is we'll just set the, let's go back a few steps here. So here we were visualizing the color. This is world space, and then we were doing our matrix to transform ourselves into local space. If we take, instead of doing it this way, if you're just using the rest position, you don't have as much information. So on the surface, everything looks okay, like the cross section. That's why you can use rest to assign textures to stick stuff. But if we look, again, doing the visualization, this is literally just projecting, streaking stuff out into 3D space, where this is actually properly like warping and distorting the coordinate system. So this is just more of like a rest projection. And then this is actually like a different coordinate space, if that makes sense. Chester C, how's it going? And if we do this one over here, this one will just be world space. And get rid of these other steps. So here you can just see as things change, the space isn't warped at all, it's just swimming. Here we've properly warped or like distorted ourselves into the cylinder's coordinate space or the local space. So doing that step, we get the most proper representation of our noise. And if we just do the rest projection, you see some streaking or just artifacts that way. So these are the three options, or just these are three options. There's probably other ways of doing things as well. It's just spread them out this way. So this is probably the worst way to do it because you have swimming textures. This is a little bit better, but as you see with the volume noise, you get some errors if you push things too far. And then this one, let's just line it up. Let's make some more room. We'll just put this one straight down because this is kind of the best way to do it. Lord Jesus. All right. Maybe these visualizers, we'll just put them by the side like that. And here we don't need any input connected. The base geo that I just made was the tube. So if you guys want to get caught up looking at the scene file, you can grab that there. All right. So now we just have this man running forever. Now I just did this time warp to make it into a loop. This is just cycling the same sequence or the same portion of your time. And then this character is just from the motion capture biped. These come with Houdini or whatever. Like if you put them, you have different options. People use them for all kinds of test things, the zombies and different stuff like that. Yeah, this is Houdini 18.5, but I don't think I'm using too many features super specific to it. If you want to check out some of the new stuff, they do have the like FBX animation import and character import and that kind of stuff. I'm not using them because they don't, if I do this kind of stuff, it's harder to distribute it with the FTP, with the links in the chat, like there's more external files. These characters, they're even in earlier versions of Houdini 13 and so on and stuff like that. But if we wanted to have some fun, we could, yeah, character import. Yeah, we could do the Mixamo. Just make sure I don't dox myself here. All right. We are in the mainframe. So you can get these characters from Mixamo that Adobe owns. We could turn one of these fellas into a cloud. I don't know which one is going to be. Maybe just a jumping, do a jumping zombie. So all that stuff should be good. And it'll take some time to build your FBX file. Just put it into the downloads and get the file path. So if you wanted to use some new features from 18.5, you can do it this way. Does this have the animation built in? I need to do the bone deform. I'm just going to get rid of the that dependency link arrow. The project from local space noise. You made some noise. It's all of these are using the same noise generator or the same VOPs to generate the noise, but it's just their input coordinates. World space, this is an unchanged asset. This one is just projecting the rest position outwards into the volume. And then this last one is actually converting ourselves into a special coordinate system that we made for the tube using the steps here to construct our matrix. So we've set up a special coordinate system. Instead of world space here, you have X, Y, and Z that looks like that. This is our special coordinate space that's local to the tube. So if you've ever, other nodes and stuff like that with like the poly extrude, they have a concept of local space like this. You can see that the the transform handle gets aligned to be in the space of the object. So that's kind of what we've done with these vectors here. All right, so you do the bone deform. So this is the new 18.5 tools that gives you access to the fun KinEffects, joints, rigs, and all that stuff. And the KinEffects stuff is interesting too, because it has, it is doing similar stuff with matrices. So if you do the doctor, visualize Gnomon. You can see similarly we have some kind of local space. These are the joint transforms, and this makes similar transforms. This is a bit different because it's not a matrix 4. This is just a rotation and scale matrix. It's not recording the position. This is some different ways to work with it, but this is beyond the stuff I'm talking about today. So we have a rest for this guy, and we can do similar stuff if I just take the local frame node and put it into the skin before we deform it with the animation or the bones. And let's get our visualizer as well. These are a little big. I think if we go to guides, all right. So you can see all of the polygons have some kind of local space. You could see if you toggle some of this stuff, the differences of what it does. And if we look at them after we deform him, you can see we're recording like the orientations and everything of the surfaces. So as he moves and changes, we're recording all of that. Like the rest position isn't as valuable because it's just the point in 3D space, but these rest space is more valuable. The deformation wrangle. The deformation wrangle is another thing that's a little bit more special. You use it if you want to deform this stuff properly, I think, because it will evaluate your operations at different positions. So it makes a little bit more sense to do that. Can do a quick look at it. Let's keep all of our nodes. Let's go to a standard globe. So the latitude and longitude lines. Random render, thank you for the tier 1. Let's go. There's also Tunalan. Forgot to mention them, but they subscribed during the off hours as well. So this is our local frame. I don't know, is my character animation? I don't know why these vectors are such different lengths. We'll ignore that for now. So if you do an operation, if we do a regular wrangle, let's just keep the display flag there. Let's just add something simple to it. We'll do p.x equals plus equals a sine of the height. So if we want to build this out a little bit, we could multiply it to a higher frequency and can offset it using time if we want to animate it. So you can see that this operation here isn't properly keeping track of the frame. I'm just making my vectors longer. This stuff isn't properly deforming with the surface, like it's not reorienting itself as the surface bends. If you do the deformation wrangle, this node is smart enough to kind of evaluate like the derivatives of the deformation or the operation you're doing. You just need to use this pose instead of p. So instead of p.x like that, you just set these to pose. And then these vectors will get properly oriented along the surface. So if you're making your own deformer and you want to properly reorient like attributes and stuff like that, this is a better way to do it. You can use the attribute reorient node. But sometimes you might get some flipping and stuff like that as things go along the origin. So like if you have maybe just a line, I don't know if I've done this properly. Somehow my line isn't getting the, I think let me just set this up here. So you can always make this yourself. If you have a line, I'm just putting like world space into the frame. So we have X, Y, and Z directions. Now this is our coordinates. I think this poly frame wasn't working that well on the line. Or I might have been just assigning those. So they're not reorienting as I do the sine wave through it. If you do the reorient these attributes, should happen. I don't know, it might not. Maybe this node isn't even working because it's just a line. So there's one thing I forgot to do here. This is a situation where you need to explicitly tell it what type of information this vector is. So these other nodes will know how to transform it. So if we say x-axis, this is going to be a vector, or you could say to treat it as a normal like that. Maybe vector is better, and it will record the deformations. So what this is doing in the geometry spreadsheet, you can see it's switching this from 0, 1, 2 to x, y, z. So this is important to know, like whether it's a color or a direction vector or point position, you need to deform it or treat it differently to reorient it and everything. So because I'm just making up these axes like arbitrarily, Houdini doesn't know what to do with them by default. I think if you do it with this node here, you can see it's getting the x, y, and z automatically. So I don't need to do that earlier. If we just keep doing this here with these x, y, and z. Then you can see here it's saying 3 floats that are a vector. Up here it just has 3 floats, but it doesn't know whether they're a color or a velocity, point position, or coordinates, like UV coordinates, or it could be any of those. So if it was a color, you wouldn't want to like reorient it or change it with the surface. So I should be getting my stuff now. It's possible I wanted to do this first. Somehow they got quite small. I'm not sure. If I do the rigid projection, looks like it's working. Here it's not transforming them properly. This is like a bit extra stuff. I shouldn't have really gone into it, but this is why you want to use the deformation wrangle to evaluate like your deformer. You could see inside of here, they are using the deformation wrangle to take care of that for me. And similarly with the bone deform, internally they're taking care of the vectors internally to orient them with the surface as well. We forgot to keep my visualizer. All right, so we have the surface information. And then let's just build this out. So if we want to make him into a volume, can try doing it with just the cloud SOP. See what happens. Looks like it works. Sometimes you don't have watertight geometry and you need to do some extra stuff, but it looks like this character is okay. So we have our volume. This stuff is getting the god tier. You got Duke Nukem. This is kind of like a Egyptian, like a pharaoh, the headdress or something like that. All right, so we have the cloud and it's just a world space voxels. These voxels is like a grid that doesn't know anything about the local geometry. So if we just bring our cloud noise over and try to do that, you can see the issues with it. This is, need to redo some of the settings for him to get him more like a cloud. And as we play it, you can see he's swimming through the cloud noise. And maybe just turn that down for a lower resolution for right now. Just trying to speed up the scene. So we can do the same idea here, and basically we need a local frame transform. So we can take these two nodes and just paste them over here. And what we have is the live point position, and then the rest, I'm sorry, not just the point position, but the entire coordinate frame. And then this will just be for the character. And then we can take our local space, local frame noise, paste it over here. And we'll just need to redirect this input. If you wanted to properly build this out into like a digital asset or something, you could make your own modification to it. And again, this is less amplitude, smaller element size. You could do, I mean, you could build this out into several HDAs. I was just talking about the cloud noise. Like if you wanted to build out a cloud noise that would accept this local frame. I mean, you could quickly, like I'm not going to get my parameters here. I would need to promote them, but if I just put this into a subnetwork and then do that, then in here, instead of doing a relative path like that, I could say, get the op input path of the subnetwork. So this is saying to use the auxiliary input or the first input of the subnetwork, or you go up some levels and whatever's wired into it. So if you were doing like entire short film or something where every character was a cloud and you needed to constantly keep applying this to different stuff, you might want to actually set up this, and you could like actually promote all of these parameters to a higher level or do different stuff like that. That's all that I was saying with the. So let's keep working on this guy a little bit. I think we can try to make him a little bit higher of a resolution. I'm going to turn off the advection strength was also too strong. This is what's causing that like streaking or whatever. Might be a little bit too much, too many features. maybe something like that. It's pretty good. Yeah, then you convert it into fuel. Yeah, I think, I don't know what the best way is to do a pyro simulation. Like there's a ton of different art direction and stuff you might want to do, but sometimes like sourcing, cross-fading him at the torso or the waist, and then the top of him is like a fluid sim, and then the bottom is this rigid cloud noise, or depends a lot what type of look you want or whatever, but yeah, you could use it for pyro source. Let's go maybe higher resolution, and I'm gonna make sure my texture limit is turned off. This will just make sure you're in the viewport, you're seeing the full detail of the actual volume. So this is the most efficient way of computing this noise. Some people will make volume deformers and stuff like that. This is going to be faster because you only have to do one operation, and that's generating the noise in the position it needs to be in, but from the local coordinate space. So you're cutting out a bunch of other operations that get really expensive with heavy volumes. You don't have to do any additional like resampling of the voxels that can like blur or smooth out information. You're just generating the noise that you need at the final position it needs to be in, if that makes sense. If you've worked with other like deformers and stuff like that, you might have gotten frustrated because they're slow, or they generate like blurry results or whatever. So if we want to keep exploring, we should be able to, this guy has some issues. You can do a polycap to close off his sleeves and stuff like that. Sometimes you can get away with making the frame like as the last step, but it's not as good of an idea because it will keep like regenerating it every frame. So what I'll usually do is, like if you're working with here we have access to the rest geometry, so we have more flexibility. But if someone just passed you an animated OBJ sequence or Alembic sequence, you would need to do these extra steps that I'm doing now. So I'm gonna make my own rest frame by just doing a time shift node and locking it. So this is gonna hold a frame for the rest position. And then you can just do point deform, but there's other ways to do this as well. If we do point deform, then we're just kind of re-parenting it with itself. You can get rid of some of those issues with the settings. So we've kind of recreated these steps that we're doing over here. And just gonna make some kind of extra labels here. So this, we want this to be our live animation. And then this input here is gonna be rest state. You could call these, I mean, maybe it's a little bit more clear. Live and rest state. So similar to these deformers, you can see the input here is rest and deformed. These are a bit out of order, it's swapped around or whatever, but it's the same idea. So if we wanted to build this out to even more of a tool or something, I could just connect that cloud. We always know it wants to be the live. And then we have less things we need to rewire. So this would be our live. It's a little messed up. And then this one would be our rest. I think the scale of these noises is a little bit different. Seagull Rush, how's it going? You're supposed to be able to adjust everything with the spatial scale. I've had problems with it before. So, I don't know why it made everything pretty slow. It might be like it's activating too many voxels. Let me just leave it like it is. So I'm gonna keep this going with this guy. And then if we wanted to, what's cooking? what's it broiling in the crock pot? I'm setting up this cloud deformer. So we're out of the woods with our technical business now, and we're just making the final animation. But the first portion, hour and a half or whatever of this stream was pretty technical, Vex matrices stuff. So I'm just going to redo these steps and do them a second time for this. And then this is going to be live state. This will be the rest. And then it looks like here it's just need to redial some of the settings for him. I don't know if I might have wired these things up wrong. It looks like it's okay. The weather guy, the storm man. I might just have a little too much amplitude here. This is a little bit better, I think. You'd set it up with the character this way. Or this is probably a better way to working with the KineFX animation. So we have this advantage here compared with the world space method. He's going to be swimming through everything. This way we're able to constrain the noise to the character. Just going to play around with these settings a little bit more. Maybe something like this is pretty cool. Let's do a quick flip book. I don't know how many frames this animation is. We'll just let it go. So this guy here I got from the Mixamo page and just exported it like that. The other one was the other animation came with Houdini. It was the mocap OBJ. So we can double check. So even these silhouette or things that are outside of him can be properly like advected or pushed outwards. That's the biggest advantage of doing this over using like the rest. If we just projected the rest position out into 3D space, we would get more of the streaking and those issues and stuff like that that I was showing earlier. It works. So I think it's possible. This character, like I should have caught this issue earlier, but I think the problem was maybe these vectors, I should have been normalizing them. So if I take a node here and do like XAX equals normalize. So just make these a unit length. I don't know if that was the issue. Maybe doing it over here. I'm not sure why they were showing up as a different scale at first. Looks like it's maybe fixing some of it. Sometimes if those, it looks okay here. Sometimes that can be an issue if these become too distorted. So yeah, that's probably going to be it for today. Unless people have other questions or anything. Let's just do this. So I'll just set up a quick little illustration or a better visualization of what's going on. Let's go back to the smaller vectors. Yeah, sorry if I stumbled through some of it. Hopefully it's clear as to what's going on. Me. Trying to think what a, all right. So I'll just set this up like that. I'm gonna copy the settings. Yeah, it's pretty, some of it's pretty difficult technical stuff. But if you want to just use this more like a tool, like you're not the developer, you're just an artist or whatever, you can as well just take these nodes, and I've kind of set these up like it could be made into a little tool somewhat easily. So if you want to just use these without worrying about the matrix and just know that you need to do these steps, you can do it that way as well. Just want to put this the other side of the axis. So like sometimes if you're working at a studio with a team of people or something like that, there's one person who's just responsible for developing and maintaining these more technical tools, and then every like animator or every effects artist doesn't really know what's like how to build it from scratch, if that makes sense. All right. So we'll make a little flip book with the 3. It's going to be a little bit slower to compute because there's all the, it just has to make the cloud noise 2 times. But it's kind of similar, like if side effects built this out into a little tool or something like that, they could make it into a node and you wouldn't have to worry about all the technical stuff. But just to share the technique or whatever, it's cool to know about what's going on or how this is built. Hilarious. This one looked like billboards attached to points. You could do it that way. You could also, there's other ways to go about this as well. Yes, it's not billboards, it's fully 3D. So it will get proper lighting and everything. I think maybe I just didn't have enough shadow strength. Sometimes with clouds, I'll turn the shadows very low so that it looks like the light is kind of bleeding in or something, or like maybe I had an environment light or something. But yeah, so there's another method you could do is like parenting billboards to the character, or if you could even parent like little 3D volume puffs to the character, or like instancing a bunch of little puffs. It's not going to be a coherent 3D noise. So that might as well be why this is just too uniform of a fluffy noise. So it kind of looks like little particles or something like that. But yeah, this is proper. This is the proper way. I don't know. I just say proper sometimes as like the most physically accurate or like true sense of representing it. This is the way. It depends. Sometimes you might want to do other methods if you need a quicker thing. If you were doing like a real-time character, you would probably have to parent the sprites and do like volume sprites facing the camera because you can't do voxel deformation in a game engine or whatever. But this is it for visual effects and just physically accurate. This is the best way I know of, at least. Yeah, it's pretty cool. I hope it wasn't too too deep in the matrices and stuff like that can get really complicated. If you miss like one small step or something like that, you've done one thing slightly wrong, your results will be completely broken. So like just forgetting to invert the matrix before you apply it or when you need to invert it or whatever. It's always important to remember that. Like here with the tube, if you forget to invert it and you're going from the live position, you're just multiplying it by itself. It's like applying a second from rest to deformed, and you just get all jumbled up or whatever. Yeah, you could do some stuff. So slices, like you would need to bake out a yeah, you could get some shadow information from that. I think maybe this stuff was just so far off because I was working at a different scale. I guess the tube I made was quite big. But yeah, this is the same idea here. This is our example. Just a simple example, like I was saying at the start, if you just work on a tube or some simple geometry, It can be quick to test with and just troubleshoot. And then this stuff is more of the final results or whatever. To bake some custom color information to the VDB? It depends how you're trying to bake it, but the easiest way is to just make a color volume. I don't know how other engines and stuff will read it or be able to work with it. Sometimes they do it with the Pyro bake. What is it? Pyro look. Post-process. No, I guess it's not this one. It was a bake volume. So here with the bindings, like you could bake an emission volume, that would be a similar idea. But yeah, so if you have a volume here that's like a density, just fill it with a value. So this is just a scalar. It's just recording the opacity or the thickness of the volume. If you wanted to bake in custom color, you'll need to make a vector volume. There's different ways to do this. The really old school way is people just merging 3 of them like that. And then you can rename these. If you just do a name SOP, this would be CDZ. Y. And then this one is X. So here you have X, Y, and Z. This is a really old school way of doing it. And then you could do like a volume wrangle maybe. You'd say color equals the sign of the Y position. You kind of get that. If you do HSV to RGB. Did I do it properly? Then this will take the hue that we're using with the sign, then the saturation and the value. So the visualizer right now is not displaying the color. If you do a slice, you can visualize. If you, by default, like a color will override the visualization. You can also just set it to no mapping. But by default, a color or a vector volume will always override this visualizer. If you just do no mapping, it's a little bit more clear as to what's going on. And then if you just do volume visualization. So I'm going to merge density with the color. And here our density field will be density, and then the diffuse field or the color, you can set it to CD.star for RGB or whatever. So this is the best way for Houdini to visualize it. If you wanted to export this like this is the information. This is like an alpha, red, green, and blue. So the same thing with an image, like an EXR, RGBA. This is the same idea as you have density, then you have your colored volume. So yeah, we can do one more distribution. If you guys missed anything, or you want the nodes, does that volume visualization data stay in for volume rendering? It depends on the shader you're using. I'm not sure if it can be a Unity 3D texture. It just depends on the shader and the stuff you're using. The information is there, but it just depends on your other like renderer or stuff like that. With Redshift, yes, you can use it. We could do material, material network. Redshift material. So instead of this hard surface, you just want to use the volume. And then density, and depends where you want to put it. So at the bottom here, they have the color channel. I think with Redshift, it will only work with VDBs. Like they haven't built their renderer to understand like the Houdini volumes. So you would want to do convert VDB for Redshift. And then vector merge to get those XYZ colors into a merged color like that. So this is CD, and that makes sense. We could try it and see what happens. So we apply the shader. You could also apply it at the object level if you want. Let's make a camera. This light, if you don't want it to be used with Redshift, because it's not a Redshift light, you could exclude it like this. Is one way to do it. And then we can do the Redshift light. Redshift as well, you need to remember to do the volume contribution. Let's see what happens. This might be too high resolution of a camera. Just do like half res. And then I think some of these volume settings are still a little bit off. Let me go live SOP level updates. So I did this color channel at the bottom here that this belongs to the emission ramp. You put it up here to do the scatter. Then you just refresh it and it looks like it works. So you can do these color channels for different ramps and stuff like that. Boom. Booyah. So these are the difference of like absorption and scatter work differently with Redshift. Yeah, Houdini does a pretty good job of like, is pretty nice just as like a visual thought process, like recording the thought process. So other softwares that use the more of the menus and stuff to do operations, like that step gets kind of hidden or obfuscated or whatever. But yeah, so you could just quickly go in with the guy here. This one doesn't have a color, so we'll take the color channel out. There he is. With the cloud stuff, usually I'm making sure that this max is a high enough value to capture the whole volume. So like the cloud noise or the cloud SOP, the density multiplier gets set at 10. So the highest density value would be 10. If you have this too low, then you'll get like this crunchy, flat, kind of, you could see the edges of the voxels. And it kind of clamps or flattens your range out a little bit. So if you're rendering stuff you want it to look like clouds, that's one thing to be careful about. I'm usually setting the shadow density lower. So that's, you want to fake a little bit like clouds, the light can kind of bounce around and like scatter in it a little bit easier. And you could also do some of it with absorption. It just depends on your workflow or whatever. But just to get something that looks generally like a cloud, that's usually what I'm doing, is making sure this range is high enough, reducing the shadow density, the shadow darkness, and that's it. Let's see how long this. Still pretty quick. You start to get some better details and stuff. All right. So I think that's it for today. If you want to check out the lighting, coloring information and stuff like that, there's an updated file. Yeah, of course. Hopefully this, sorry if some of the stuff is a little bit complicated. If you go back and step through some of this stuff and try to build it from scratch or do that stuff, you can learn it just through repetition or kind of like trial and error and seeing what works and what doesn't. Or if you also just want to work more like an artist or whatever, feel free to grab these nodes and reuse them this way or whatever. Yeah, and I don't know, it would be interesting. I haven't had a chance to mess around with it too much, but you might even be able in the future to set up something that would hijack the joint local axis and use that for volume coordinates and stuff like that as well. It could be a cool thing to try with that. All right, that's it for today. I hope everyone has a good Thanksgiving if you're in North America, if you celebrate it. I'm not sure about Friday. I might be taking the day off for the holidays and stuff like that.